So I'm going to show you how to make this. This is a multi-layer gear made on a laser cutter, cut on a laser cutter, and using alignment pins to make sure that the teeth of the gear align correctly. This particular design is in principle rotationally symmetric, but getting the teeth to line up can be somewhat tricky, and so using registration pins can make that much easier. Why you might want to do this is dependent on your needs, I guess. In this case, I just wanted a thicker gear. I didn't really need to do that for this particular gear, but if I'm making like a pinion or something like that, pinions, you'll want them to be somewhat thicker. And cutting that in a single go with a big chunky piece of wood is actually a pain in the ass. You might need to also do this for materials that are kind of hard to cut. So, you know, Delrin is a pain in the ass to cut. And if you can make whatever part you're doing out of multiple layers of Delrin, that can be a lot easier to do with registration pins. So yeah, let me show you how to do that. So the first kind we're going to take a look at is very simple. You just have 3 holes for the registration pins. You want the holes to be in a kind of right angle. That's a very convenient way of doing this. And what that does is it gives you an asymmetry. So you can only put these together one way, right? You can't put them this way because the holes are in line. You can't put them this way. You can't rotate it. If you only had 2 holes, like you had this, you could put them this way or 90 degrees or 180 degrees apart like this, and that can be undesirable if you have a part that has some like asymmetries to it inherently. These gears don't, but you know, your parts might. And so if you just make them into this, I don't know, you can think of it like an L, then because each side of this triangle is a different length, there's only one way that these pins can go together. And so you just take one of these pins. I'm just using these little nails. Doesn't really matter what you use as the pins. Nails work pretty good. You can get these thin ones. As long as the nails are relatively circular, then it works fine. If they're not circular, that can cause some problems. So you can put 3 pins through. You can put 2. It actually doesn't really matter how many you put. I'm going to put 3. I'll grab another one. As long as you have at least 2. But putting 3 does sort of force you to actually align things correctly. You put them through one of them, and you can use it as like a little table, and then push them through the second one. And you want to be careful that you don't break the material. You saw on the bottom one that actually you could force some, because this is plywood, you can force some of it up through out, right? You can separate layers. So you want to be careful about that. Yeah, see, like that. It's not good. And once you put them all through, you know, this is pretty well aligned. You want to check, make sure that they're not really twisting or anything. That can happen if you have like a pin diameter that's relatively close to the thickness of the pieces that you're aligning. They can sort of twist relatively easily. This, it's not really bad at all. This is fine. So you would glue this together. You know, you go through here with like a brush maybe, or before you put these on, you know, before you put them together, you glue them together. And then you just clamp them together for gluing and just leave it. One thing to be aware of is that if you're trying to do this with a very, very small part like this, you know, you can give it a go, right? You can cut these holes and try to align them together. But because the spacing between the registration pin holes and the edge of the material is quite small, this can break, right? This obviously is not good. So this doesn't really work for very, very small parts like this. I've gotten this to work with little pinion layers like this that are a little bit bigger. But for ones this small, it doesn't really work. You have to make sure that there's enough space between the holes and the edge of the part so that there's enough material that it won't break. Thicker materials, this is a very thin, like this is, you can see this is like way thinner. There is obviously very, very thin material, and that's going to break more easily than if you did it with 1/8 inch or 1/4 inch. So you just sort of have to play around with these, do some tests first to make sure that you're not using a material that's too thin. So one interesting thing you can do is if you're trying to cut something, these are quite small, so you probably have enough material to cut one of these regardless, but if you don't have enough material to cut something, so for instance, pretend that we didn't have a piece that was this big, but we had pieces that were a little bit smaller, and you need to make something roughly this size, right? Whatever size you need to make, but in this case, this is the size I was making. You can actually cut multiple pieces. You can cut the gears in sort of half, but you do need to have more registration pins. So let's see, let me arrange these and see how these go together. So there you can see there's like an L, and then this one, there's another L. Let's flip it this way. Not like this. So the first thing to notice is that if you look at the L shapes here, right, of these inner holes, the split is 90 degrees apart. And you want to do that so that when you layer them together, each of these pieces is layered on top of each of these pieces is layered on top of two other pieces, right? So this piece is going to be layered on top of both of these, and then this one is going to be layered on top of both of these as well. But then what you need to do is you need to sort of think about the quadrants that are formed by the cut. And so these holes here are enough to fix these two in position relative to each other. And so if you place a pin through two of them, okay, that one. Right, now you can align these two pieces. Right, and these won't move relative to each other because they're fixed by these two pins. And then if you glue those together, that'd be fine, right? These would hold relative to each other. And you just do this for all of them. And you might be wondering why the holes are arranged in a funny way. And part of the reason for that is to, again, reduce the symmetries. You want to make it so that there's really only one way that each of these things can connect. Now, it's a little bit more important in a piece like this because there's just way too many ways that these could be flipped and rotated and whatever. And so I tend to use this pattern where if you think about the quadrants, one quadrant, the top left quadrant, has these two arranged sort of along a radius. These two, the bottom left quadrant, these two are along a chord that is sort of 90 parallel to this radius. And then the top right has these two sort of aligned with the horizontal, and these the bottom right has these two aligned with the vertical. And there's no way to, like, you can't flip this and put it together this way. you couldn't have put this one, up here. That just wouldn't work. You could put it this way because these two would align, but then wait, the holes here don't align. So this configuration actually is very convenient for forcing you to get everything in the right orientation. Now this is a bit trickier to glue, so you might want to do something like this where you put two of them on first, and you glue this one to each of these, and then you put glue here, and then you would then layer these together again. Honestly, you should obviously just get like appropriately sized material, but sometimes you don't have that. Sometimes your materials are expensive and you got to get every little bit out of it. There's all sorts of reasons why you might need to sort of make pieces bigger than what your material can currently support in a single cut. And so that's at least one option that you can use. This, I think, will cause structural problems, right? This is not going to be as strong as if you had a single piece of material because this break in the middle has nothing holding it together. So if you had to pull this apart, right, the tensile strength along this axis is half, right, than what it would be. Like along the x-axis, it's half than what it would be along the y-axis, because the y-axis, you'd be pulling all of these fibers, right, in this wood. But in this direction, well, sorry, in this particular case, actually, it wouldn't be any different because the split on the other side is along the x-axis and not the y-axis. But if you think about like if the back was, let's say, solid, then because there's a break here, pulling it apart along the x-axis is going to be a lot easier because of that break. You're only really having a single layer holding it together, whereas if you're trying to pull it apart this way along the y-axis, you're pulling both pieces of wood apart, and so that's going to be stronger. So you should keep that in mind if you're going to use this for like something structural, where it's going to be under tension. Under compression, it shouldn't really matter. And if you're bending it, obviously that's going to have a similar effect, right? Because in this direction, it splits, but in this direction, it's not going to. So those are considerations for this kind of multi-layer approach. For something like a gear, it doesn't really matter all that much because the gears are just going to be rotating, right? They're not going to be bending or being tensioned or anything.